of regular polygons. What we will do first is go into just some vocabulary terms first, and then we'll discuss where the formula for the area of a regular polygon comes from, and then how to solve problems incorporating those formulas. Let's first start off with these terms. The term regular refers to not ordinary, but actually something very special. What it means is that a polygon is both equilateral and equiangular, meaning that all the sides and all the angles are congruent. An apothem, or apothem, depending on which way you want to pronounce it, is the distance from the center to a side. And it doesn't matter which side because it's regular, meaning that it's all equilateral and equiangular. Now, when we talk about the distance to a side from a point, we always go the shortest distance. And that shortest distance to a side, whether it be a segment or a line or a ray, is always going to be at a right angle. These are examples. So from the center to a side at a right angle. Now you'll notice that you can draw one for each and every single side. So if a figure has, say, 6 sides, you can draw 6 of these. Now in drawing this, not only does it hit at a right angle, what it'll do is it'll split this side into 2 congruent segments, which means that when drawn, what it does is that it connects to the midpoint of a side. So you could say that it's not necessarily the distance from center to a side, but rather the center of a polygon to the midpoint of a side, and that would work just as well. Now the radius, we talk about a radii when it comes to circles, but with regular polygons, we state that they also have a radius, and that it would be the distance from the center to a vertex. So you would be looking at it like this. Now, since there are just as many angles as there are sides, you would have just as many radii. You could draw one for each and every single angle. So why do we call this the radius? Well, that's in reference to circles in a sense. If the figure were inscribed within a circle, that would be the radius of that particular circle. So that's where the term comes from. So let's do an example. Let's say you're given something like this and you're to determine these 2 particular angles. You will note that the radii are drawn in for each and every single angle. Well, one of the things you should recognize about all regular polygons is that if you go around one particular central point like this, all these angles would total 360 degrees. Another thing you should recognize is that just like with a circle, each and every single radius is the same length. They're all congruent. Now, since this is a regular polygon, that means all the sides are also congruent. That means each triangle is congruent because of side, side, side. And since each triangle is congruent, that means all the corresponding parts are congruent, meaning each angle is the same. Therefore, in the middle, it's not just that this is x, but rather all of them are x. That is, all the angles around the center point. So if you add all these angles together, what you get is this. Now keep in mind there are 5 triangles, so that's 5 x's there. Which means from this, since each angle is the same, if you divide both of these by 5, what you get is 72. So that's your solution, at least for x. So what about y? Well, keep in mind that this triangle here is isosceles, and we're just focusing on one triangle here. This triangle is isosceles, and since 2 sides are congruent, that means that the angles that are opposite those 2 sides are also congruent. Or you could rationalize that since this is the one side that doesn't equal the other 2, that makes this side the base, and therefore this angle and this one are base angles, and the base angles would be congruent. So this is y, and this is 72, and since this is a triangle, all the angles will total 180 degrees. So there we are. Then we would just simply solve algebraically. and that would be our solution. Okay, now let's get into area. I'm showing here a regular pentagon as our example. You could really do this with any regular polygon. What I have here labeled is the apothem, or apothem, and this is S, meaning the length of a side. Remember that since it is equilateral, all the sides are the same length, and all the apothems are the same as well. The area for this regular polygon is equal to the apothem times the length of a side times the number of sides divided by 2. This area formula actually comes from triangles, and I'll show you real briefly how we derive it. Let's say we draw on the radii from the center. Again, you'll note that what we have here are congruent triangles, and since there are 5 sides, then we have 5 congruent triangles, with this one here with the apothem drawn in the middle. So let's go ahead and just focus on this one triangle. This bottom here is the same, it's S. Now, do you recall the formula for the area of a triangle? You may recall it as the base times the height over 2. In this case, the base is S, and the height is A. Thus, its formula is S times A over 2. Now, since there are 5 triangles here, if you wanted the total area, you would just take this thing and multiply by 5. In other words, you would multiply by the number of triangles, or just by the number of outside sides here. And that's where this formula comes from. The A and the S go here, and the N represents the number of triangles, or sides. It's all the same. By the way, it should be noted that the perimeter of this figure is S times N. If you think about it this way, there are 5 S's. So the perimeter of this particular polygon is 5 times S. See that? If this were a 6-sided figure, you would multiply by 6 instead, by 7, etc. So because of that, this particular portion here, S and N, is simply the perimeter, and that leads us to a different version of this formula, and that's A times P over 2. So either one works. Now, as a general use, you would typically stick to this version. You would use this only if you were given the perimeter or if you were asked to determine the perimeter. Let's determine the area of this particular polygon. Let's start off by writing our formula first. Now let's go ahead and plug in our values next. We know the apothem is 5.2, and the length of each side is 4. N, by the way, is 8, and that represents the number of sides. Now, when you're counting sides, it is recommended that you tick them off, like so, like 1, 2, 3, 4, 5, 6, 7, and 8. This way, you're not forgetting where you started from. A lot of times, students will count off sides but not mark them, and then they'll end up counting one of their sides twice. Okay, let's finish this off here. We're going to multiply the top here, and then we'll divide by 2. And that's our solution. Okay, let's do another one. Let's this time do a problem where we already know the area. So the area is 135 square units. Determine the length of each side here, x. Again, as stated before, let's write the formula first. You'll note that we are not given perimeter here, so we will not use the perimeter formula. And then now let's plug in our values. The area is 135, so that will go here. The apothem is 9, so that goes here for A. The length of each side is x, and then n is the number of sides, and if you count them accurately, you'll put 5 right in here for n. And now we are ready to solve. To solve this, let's first get rid of this denominator here. What we're going to do is multiply out both sides by 2. The reason why we do that is this. X is what you want to solve for, and it's surrounded by all these values. So we want to get rid of these values in order to get to our solution. Now, since we're working with a fraction here, rule of thumb is you'll want to get rid of the denominator first. Working with fractions tends to be more difficult for students, so we try to solve that issue almost immediately. 2's reduce out. This part gives you 270. This part here, that's 9 and 5 together to give you 45, and then the x just simply drag down. To finish off, we just simply divide by 45, and then we get our solution. Okay, let's do another one, only this time without a picture. The area of a regular polygon is given as 492, and its perimeter is 80. So what is the length of its apothem? Now you'll notice it tells us perimeter here, so when we write the formula, we're going to use the formula that has perimeter. There we are. Now let's go ahead and plug in our values. The area is given as 492 right here. So that'll go in place of here. The perimeter is 80. So that's going to go here. There we are. And now we can go ahead and solve. We can solve in one of two ways. This is probably the easier way. Note that we could reduce 80 and 2 here, so we'll just go ahead and do that. 2 and 80 reduce to give you 40 on top and 1 on the bottom. Then just divide both sides by 40 and we get our solution. Okay, now let's do one last one. Let's determine the area of this particular polygon, but only knowing its radius here. Now this particular polygon is a hexagon. You might note 6 sides, and there's something very special about this. Let's first kind of explore here by drawing in a few things. Since our formula involves the apothem, let's go ahead and draw in the apothem, and since we have a radius, let's go ahead and draw in another radius. Recall that if you were to draw in the radius to each and every single vertex, you would get congruent triangles. Since there are 6 sides, there are 6 congruent triangles. You may also recall that all the angles here in the middle are the same. So if we wanted to know each angle, let's say we call it x degrees, you would add x plus x plus x plus x plus x, that's the whole thing here, plus x, and that would equal to 360 degrees. That means each angle in here is 60 degrees. So now that we know that, let's just focus on one of those triangles. Recall that the radii are the same, so if this is 10, this is also 10. Because of that, since 2 sides are equal, that means 2 angles are equal. So if you calculate, and let's say we'll call this y here, if you calculate how much each angle is, that's 60 plus y equals 180. What you would get is that both of these are also 60 degrees. So that's an equilateral triangle. So let's look at this more closely. We have drawn in here the apothem. Let's just focus on this particular part of the triangle, since these two are the same. When you draw in the apothem, you get a 90-degree angle. So what you have here is a 30, 60, 90 triangle. Recall that the apothem splits this side in half. Now we know that each side is 10 because it's equilateral, it's also equiangular. So we know this side is 10. Since it splits this in half, that means that this portion here is 5. Now that doesn't mean that when we plug in our numbers for the formula that 5 would go here. Again, each side is 10. It happens to be the same length as the radius. That's not a general rule here, but it's particular only to hexagons. So we know that 10 is going to go right there. We already know there are 6 sides, so we know 6 goes here. What we're trying to do now is figure out what that apothem is. So that's the reason for this here. So going back to the triangle, 10 here, 5 here, and to focus only on this particular length here, you could do this now in one of two ways. You could use the Pythagorean theorem. You could go a squared plus 5 squared is equal to 10 squared, and then solve. Or you could use your properties with special triangles, 30, 60, 90. With the 30, 60, 90 triangle, you may recall that this is the largest side, and the largest side is always twice as big as the smallest side. So that should tell you that this is the smallest. The medium side is going to be root 3 times bigger than the smaller side. So if this is 5, that means that this length here is 5 root 3. So what that means is that 5 root 3 is going to go in for A. So let's go ahead now and plug those in, since we now finally have all our values. And now we're ready to solve. Let's go ahead and multiply these together, and if you just have a calculator, you can go 5 times the square root of 3 times 10 times 6 and then divide by 2. If you're doing this by hand, then what you would do is you would just multiply 5 and the 10 and the 6. That would give you 300. And then just divide this through 300 over 2. And that would be it.